Visual Studio 2010 is just about to come to life, and the plan is currently to support it mid-year, once it's out already. So you can expect that within 6 months, basically, there will be a minor release update and support for it. So to demonstrate Nexus, what I just did is fired up Visual Studio, so 2008. This is, and loaded it's called a game demo from Emergent that's called Mangled Metal. So when you actually purchase the engine, the middle resolution, there's a variety of game demos that are shipping with it to show you how to program the game engine. Mangled Metal is actually one of them. And what I did here is load a project where you can have all the source code basically for that little game sample.
Can you,
and Sebastian, this is Visual Studio 2008.
Yeah.
What every programmer in the world uses.
Yes, exactly,
today.
exactly.
You're showing exactly that.
There's nowhere around it. That's the default path to programming any game, right?
And you can see real quick describe what the hardware is here, so everybody knows what you're.
Yes, right. I'll get to that. Okay. Nexus here is so you can see that Nexus is installed in the system and is accessible from a menu where you can actually start the various activities for debugging and profiling and whatnot. Now, Tom, yes, it's very important to note that my mouse here is seamlessly moving from one screen to the next. And for each screen, actually, I have a totally different OS running. The host right now is running on its own Vista 64 system. And I have also a guest OS running another Vista 64 system that has nothing to do with one another. This is running on the HP Z800 SLI multi-OS system that allows us to essentially, on one box with 2 GPUs, run 2 different OSs that have their own dedicated GPUs, such that you can do remote activities on the local system. Okay? Does that make sense to everyone? I know it's kind of, it's pretty weird, it's pretty wild, cool. But it is pretty cool. It is pretty powerful. And because of the use of the parallel software, it's easy to go from one system to the next. My mouse here is not moving any farther than, just across the screen. How cool is that? Right. So, in addition to that, we have a Nexus monitor running here. If you want to see it, basically, this is essentially the software that has to run on a target system to respond to the various requests, the various services requests from the host. So, without giving you too many details, now the first thing I'm going to do is basically run a graphics debugging session of this Mangled Metal game demo onto the system. So what's happening here, obviously I had built the project beforehand, so we didn't have to rebuild everything and I didn't want to waste any more time than we should. And what's happening here, our file system has actually synchronized the latest files onto this OS. So essentially, we've built locally, and now we have the ability to upload essentially the build or the only files that change between the last time it ran onto our target system. And now we're just launching the system, the application remotely on our guest OS. So it takes a little while to load, obviously, because it's a game data, right? And you can see here a typical environment where there's a main robot that can run around. I'm not going to go fight the enemies, but if we were to go and fight those guys, it would happen. So the first thing we kind of notice on this bot here is that there's some weird rendering artifacts here. I'm not sure what's going on, but it's supposed to be shiny metal, and the artist is telling me that it's not behaving right. So, and it's true. There's something weird here. So let's use Nexus to actually get quickly to the bottom of this issue here. So going back to my host, I can easily, from the Nexus menu, enter what we call the frame debugging mode, which is essentially freezing the application on the guest system and uploading all the data to the host and allowing the programmer to either scrub on the target directly, where I can easily essentially go one call at a time to understand and peel off essentially what happened over the period of a frame, to understand how things happen, or even do that also on the host here. And obviously there's some communication going on, but everything is asynchronous, and I can get both options. What I'm going to show you here is now that I have uploaded all the data here, I can actually more comfortably mine the rendering the data onto the host. And for that, I can easily drill into what we call a draw call. From that draw call, I can see the current frame buffer, and using our hardware debugger, I can actually select a pixel, and by doing this, it's going to collect all the draw calls that touched or potentially touched this pixel over time. What is cool here is this is not software, this is actually all hardware. We have actually created conditional breakpoints on the GPU to notify the host whenever, and when I mean the host here is notify the CPU, right, the program, the Visual Studio Nexus, to notify that actually a breakpoint was triggered at this pixel location. Okay. And as a result, I have basically a list of all the draw calls that happened over time since the very first clear at the beginning of the frame until the very last draw call that modified it. Another interesting point here is to note that for a given draw call, I have actually many hits. It's because for each triangle that could potentially create a pixel for that location, I have gotten the notification from the debugger that it happened. So for a given draw call, I know actually exactly how many times it touched basically the frame buffer at that location. Right? And what is beautiful here is because of our debugging capabilities, I can easily select this draw call, which is going to highlight it here, which is going to go into an advanced mode here where I can actually understand what happened. So this is a body part of that bot here. I can also look quickly at the textures, so we can see that we are reading the GPU memory actually, and we are decompressing it on the fly. There's no, again, this is a real debugger here. There's no funny business in terms of software emulation or anything. This is reading data on the GPU as it is in video memory and displaying it to the programmer. And you can zoom in, you can inspect it, you can go back. We use a whole kind of wet black navigation system as well, so you can easily drill into more details and go back up to where you were. You can look at your Z buffer, see what's going on. And for our purpose here of debugging or rendering glitch, I can easily, through the DirectX diagram, this is essentially the pipeline of DirectX, click onto the pixel shader, access the source code that was used for the rendering, and set a breakpoint using F9 the same way you would do it on a CPU. And here, I just hit the breakpoint. For those of you who may be familiar with the debugging experience in Visual Studio, when this yellow arrow it's showing you essentially where the program counter of the processor is right now, and where the processor is stopped at. So here, I just broke basically the GPU at this particular line of code in this draw call. You will notice on the guest, everything is frozen. I had this little moving selection here. It's all frozen because the GPU is actually frozen. Nothing is going to move here. The time is not going to move. The cursor may show up because it's a hardware cursor, but that's it. So, because I knew there was something wrong with this. Oh no, yes. Before I move on, let me show you also the current state of the GPU. For that, we have what we call a graphics focus speaker, which essentially tells us for that breakpoint that was hit, it is actually corresponding to certain what we call quads. The GPU processes pixels in quads, in 2x2 basically sets of pixels, which means that when we hit a breakpoint, it's essentially at least 4 pixels stopping, if not more, because it may be the same draw call. In that particular example, we have actually a bunch of quads that stopped here and stopped here, and they all correspond to that same shader code, at that same pixel, that same line location, but at different locations on the screen. In my, when I hit that breakpoint, I am focusing on 1 pixel, and the position of the pixel being debugged is actually displayed as an intrinsic variable into your variable panel. If I were to go into a different location here, I can easily select, let's say, a different location. If I double check here, if I double click rather and select a different pixel location, it will update all the variables that belong to the pixel location. Okay? And then, so the next thing you can do is step through the code, and, press F10. And that will basically allow you to step into each function. So now this is a fairly complicated shader, and I know something is wrong in a reflection application. So here I'm going to set another breakpoint. Let me kill this. Set another breakpoint and then press F5, which means execute from where I am right now all the way to this location here. So I press F5, and stopping that function, I can step into it the same way again you would do it, on the CPU, and step through the code. And now I can notice that I have this extraneous factor being multiplying rather my world reflection vector, which is essentially canceling some of the components. So again, I've noticed the bug in the same way you would essentially at this point in time stop the application and fix the bug and recompile it and rerun it. This is exactly what we're going to do. The GPU is stopped. I'm going to kill the session. Boom. It resumes the GPU on the guest OS. I can easily fix my code now by loading the right library and fixing my code. I know magically that this is working right here because I know my code so well. And I'm just going to rebuild it. It's going to take a second. After rebuilding the library, I need to link it again, so I need to trigger another build of Mango Middle. In the meantime, I need to erase my cache, because the Embryo engine is smart about compiling and minimizing compilation. And once this is compiled, we can rerun the debugger again. So hopefully it will be a bit faster this time to load up, because the data should be more readily available. Any questions in the meantime?
Will you be running any programs, educational programs or training programs for
What kind of programs? I'm sorry.
training or education programs?
Oh yeah, so we have actually a beta program right now that is open. We have actually 3,500 developers that apply to the program. About 1,000 have been enabled because we don't want to be overwhelmed by the success of actually Nexus. But yeah, so we are doing. There's a beta program going on right now. We have also videos and documentations being built. We have also samples shipping with Nexus. To teach you kind of the basic of how you go through GPU debugging. So now, just to finish this off, you can see, hopefully I fixed my, yeah, you can see now that actually the reflection is properly dealt with, and my robot is capable of shining better. So again, the point here is, this is a revolution in terms of GPU programming. We are really bringing the level of how one can actually debug the program and profile your application in a way that has never done before for GPUs. And it's really putting the GPU at the same level as the CPU in terms of debuggability, in terms of now being able to enable more people to really program the GPU ever before. You can foresee how tessellation shaders can be debugged, and those are actually very complicated to program. Also compute shaders, compute kernels, can now be debugged in the same way you would debug C code on the CPU. There's no difference at all. You can access the GPU memory, you can read it. Everything is really as native as it is on the CPU, but it's a revolution for the GPU. And Fermi enables that. It's the combination of Nexus and GF100 that is really bringing this level of sophistication.
Awesome.
Okay.
Thanks, Sebastian.